Hello dear students, how are you all? I wish always be well. In today's video, I am going to explain you acceleration due to gravity at an altitude. At certain altitude means what you know? At a certain height. Okay, so at the Earth's surface we have studied the acceleration due to gravity is gm by r square. Now we will try to find that what would be the gravitational acceleration, that is acceleration due to gravity at certain altitude. So let us try to find out it. So suppose this is our Earth and its radius is r. Suppose any object of mass m is kept at height small h, then if object is kept at Earth's surface, you know gravitational acceleration due to gravity G equals to gm upon r square. Now if the object is kept at height suppose r plus h, then G equals to what? G at certain. So when you are taking the gravitational acceleration certain height, then what it would be? So you know capital G is constant, so we will write it because G is constant in universe everywhere. Okay, so G is constant. Mass of Earth is also constant. Fix it is because you are not breaking this Earth. So mass of the Earth is same. Now what? And the r square. R square is what? R square is the distance between center of the Earth to the body. R is the distance here. The r square is the distance from the center of the Earth to the body. Now at certain height h, the gravitational acceleration equals to what? G is constant, m is constant, and now r square is how much? R square is r plus h. R plus h whole square. At the place of r square, you know general formula for G equals to what? Gm upon r square. R square is what? The distance between the centers of the two bodies. Okay, so see here the distance between the center to the body is what? It is r plus h whole square. That's what r plus h. So we have done r plus h whole square. So up to here it is clear. Now, so we will find the relation between this gh and g. So that is the value, that will be the value of the gravitational acceleration at certain height. So let's try to find out. Now gh upon g. Now we'll do gh upon g by dividing second equation by the first. Second equation by dividing second equation by the first. So it will be gh upon g, that is equals to, you will write first of all value of gh, it is gm upon r plus h whole square, divided by the value of small g is how much? It is gm upon r square. Now this gm is cancelled. You can do it on another step. Now write like this: gm upon this r plus h whole square, and this one is also in divide, and this one is in divide of this, in division of this division, this number. So it would be r square upon gm. Now gm will be cancelled. Then you will get r square upon r plus h whole square. Now you can take r as common. I will tell you how. Suppose I am writing here r plus h. Okay. So can I write it r? I can take r. Can I multiply here r upon r? R upon r. Now this will I will take r as common. So r equals to 1 plus h upon r will be left. Okay. If it is square, whole square, if you are taking whole square of it, then it will be r square 1 plus h upon r whole square. So shall I write here? So I'll write here r square upon r square. At the place of r plus h whole square, we'll write here 1 plus h upon r whole square. Am I clear? Okay. Now this r square will be cancelled, and it will be 1 plus h upon r whole square. Now it will you can reverse it. So it will be 1 plus h upon r to the power minus 2. Understood? How this expression came is clear now? See, if you will take r plus h, I have taken r plus h and I have multiplied r by r. It will be 1 only. So no effect will be there. 2 upon t. If you will multiply by 2 upon 2, it will be same. Similarly, I have multiplied here r upon r. So now this expression, and now I have taken r as common. If you will take r common, it will be 1 plus h upon r is left here. So h upon r. Then since it is whole square, so I am taking the square of it. So square r square 1 plus h upon r whole square. So I have written here. Now r square is cancelled, and we got 1 upon 1 plus h upon r whole square. This will be reversed upside, then it will become 1 plus h upon r to the power minus 2. Now I am writing here. Here I am going to write. So this 1 upon, we know one formula by the binomial expansion. We have studied binomial expansion. 1 plus x to the power n. 1 plus x to the power minus n equals to 1 minus nx plus n minus 1 upon factorial 2x square minus n minus 1 n minus 2 x cube upon factorial 3. This is the formula, and so on. Okay, like this we have formula. Now I will try to find the value of 1 plus h upon r. Okay, so I am writing here at the place of this 1 plus h upon r to the power minus 2. Now look at the expression. At the place of n is 2 and at the place of x is h by r. So I will substitute these value in these equations. Okay. So now by using this, you know, that is equals to, now see, at the place of x is h by r minus 2 minus n. So at the place of n you can substitute 2. So I am substituting in this formula. So 1 minus n is 2, x means h upon r, 2h upon r. Okay, plus n again is n is 2, so 2 and n minus 1, 2 minus 1, x square means what? H upon r square. So h upon r whole square. Okay, divided by factorial 2 minus and so on. Up to here I am writing. Now look at the expression. If h is very small, then this term will be very small. You know, r is what? It's a 6400000 meter. 6400000 meter. This much. And height, height definitely you will take 100 meter, maximum 100 meter, 200 meter. If you are taking height 100 meter, 200 meter, or so it will be, see, it will be 0.0000 something. So if 0.00, suppose 48 it is. So 0.00048, if you will be squared, then it will be very less quantity. So we can neglect the higher terms. Similarly, the next term also will be more higher, because here it is x cube. Here it was x square, then you got 0.00048 square, means 0.000000 square of 48. Okay, so this value will be very less. Now, less than 1. So that's why we are leaving this term, the higher term, and we will take only this term. Okay, so I am writing here after this one. So I am writing here. So g equals to how much you got? This g equals to this much you got. Gh upon g equals to, you got this expression. Okay. Now what you will do? So gh equals to what? So since we are neglecting all these terms, so we will write here 1 minus 2h upon r. Gh upon g equals to, because we are neglecting these terms, so we will take only this term. So this one, now when you will solve it, you will get gh equals to g into 1 minus 2h upon r. So gh, gravitational acceleration at certain height, is this. So we have derived this value, gh upon this, gh equals to g 1 minus 2h upon r. Now if you will use any if in any numerical, the value of h is very small. If value of h is very small as compared to radius of earth, then you will use this formula. Okay, but if h is means considerable in as compared to r, like 3200 kilometers or 3000 meter, 1500 meter, then you will use the last formula what I wrote. Last formula was GH upon G equals to 1 minus H by R to the power minus 2. Okay, so this formula, or simply you can write 1 upon 1 minus H upon R whole square. Okay, so if H is a large value, H has large value, then you will use this formula for the numericals. But if H is very small as compared to radius of Earth, which is what? Which is equals to 6400000 meter. Okay, that is 6.4 into 10 to the power 6 meter it is. Okay, so if you will, this H is less, almost very less as compared to this radius, then you will use this formula. But if it is considerable as compared to R, then you will use this formula. Okay, so these are the values of gravitational acceleration at certain altitude. Now one more important conclusion comes from this formula. Look at the expression, gravitational acceleration at certain height will be less than the gravitational acceleration at the Earth's surface. How? That I am going to explain you. See, since it is G minus, see, 1 minus 2H upon R definitely will be a less quantity, less than 1. It would be less than 1 now. If a G will multiply with the less than 1, any value less than 1, like 0.78 G. So now see, the value of altitude, gravitational acceleration at certain altitude is decreases from G to, it's 7.8%, 78% of the G at Earth's surface. Means it is not G, it is less than G. It is 78 upon 100 G. Okay, so it is less than gravitational acceleration at altitude, at Earth's surface. That's why, so you can conclude from this formula that gravitational acceleration decreases when we move from the Earth's surface to certain altitude. Okay, so gravitational acceleration decreases. From here you can conclude, right, that GH or gravitational acceleration decreases when we move from the Earth's surface to certain height. Okay, that's why our acceleration due to gravity decreases at height h. Your weight is, suppose your weight is 50 kg, now 50 Newton at Earth's surface, then your weight will decrease by certain amount, like 49.8, like this much of Newton at certain height. Why? Because we know weight equals to mg. So mg equals to 50 Newton. But if you will move, if you will substitute here, at you have moved at certain height. Suppose you are on a mountain, then your weight will become, your weight at height h will become mgh, and since gh, value of gh is decreased from small g, then this value of weight is also decreased. Understood? So this is the important concept. I hope it is clear to you all. You will solve numericals based on these formula. You will in the question it will be given the values of all these terms. You will substitute and finally you will find the answer. I hope it is clear to you all. Okay, then study well. Take care all of you. Bye bye.